Chapter 5, Section 5 in the 7th grade textbook is entitled Graphing Linear Functions. That's really what this chapter is all about, is about graphing different types of lines. Really, you'll spend a lot of time in an algebra class talking about that exact topic, many, many weeks, if not months, just talking about graphing lines, because there's so many different ways to do that. And here is the first setup for us. Now, this first setup here for us, when we're talking about graphing linear functions, is going to be all about what I call the table method of graphing. The table method of graphing requires the most amount of calculation, really the most amount of work before we can start graphing. But what's nice about the table method is it works for anything, not just lines. I can graph any function with the table method. So let's go ahead and take a look at what we're talking about here today. We're talking about linear equations. That's an equation whose solutions form a straight line on a coordinate plane. An equation whose solutions form a straight line on a coordinate plane. So all they're saying there, as you can see based on the root word there, is it's going to make a line. Linear function is a function whose graph is a non-vertical line. Function whose graph is a non-vertical line. All right, let's go ahead and take a look down here. Question number 1. They're asking me to graph the linear function y equals 4x minus 1. Okay, so the first thing you see here is this table, and that's where we have to start. That's why this is called the table method of graphing, because you have to make a table in order to graph. What you're going to do is you're going to choose some x's that you want to input into the function. And you can see in this particular question, they happen to choose 0, 1, and negative 1. You can choose any numbers you want here to graph, anything you want whatsoever. The thing is, you're going to have to then come down here and graph it. So if you want to pick the number of 1,000 for x, you can. But then you're going to have to make a coordinate grid here that goes all the way out to 1,000. So chances are you want to pick some smaller numbers to work with. Generally, I'm going to tell you to work with some positive, some negative, and 0. So their list of 0, 1, and negative 1 is not a bad list. So after you pick your own x's, what you're going to do is you're going to go ahead and change x into the equation in each one of those values. And after you do that, you're going to figure out what it equals. And that's going to be what they call the output. All right, so if we take a look at that here, let's get rid of my marks so it's easier to see for you. The first time through, we decided we want x to be 0. So if I change x into 0, it says 4 times 0 minus 1. Well, 4 times 0 is 0, minus 1 is negative 1. Second time through, I'm going to change x into 1. So when I change x into 1, it's 4 times 1, which is 4, minus 1, which is 3, which is what you can see we have right here. And then the last one with negative 1, 4 times negative 1 is negative 4, minus 1 is negative 5, which is what you can see they got right here. Okay, now remember, when we graph in the coordinate plane, we graph a set of points called a coordinate pair, or an ordered pair. All right, so what they're doing here is they're combining the input values, our x's, with our output values, our y's, to come up with that ordered pair. Remember, it's always written x comma y, so we always put the x number first and then the y number second. So that's why they have 0 and then negative 1 here. 1 and then 3 here. Negative 1 and negative 5 here. Okay, so now that I have that list of points, now I'm going to go ahead and graph that set of points there, and that's how I'm going to end up making my graph. Now, as we take a look at what we're graphing here, the first point we have to graph is 0, negative 1. So remember, this is the x-axis, the one that runs left to right. This is the y-axis that runs up and down. So when I'm plotting 0, negative 1, I'm going to 0 on the x-axis, which really means I'm not moving right or left at all. And I'm going to negative 1 on the y-axis, which is right here. All right, well, if I put my fingers together where those meet, it's right there. All right, so I put my dot there. The next one I have is 1, comma 3. So 1, comma 3 means I'm going to go to 1 on the x-axis, which is right here, and 3 on the y-axis, which is right here. Pull my fingers together to where those meet, right here. And that's the point 1, comma 3. And then the last point there that we had, the last point is -1, -5. So that's this guy down here. So we went to -1 on the x-axis and -5 on the y-axis, and I pulled my fingers together to where those meet, which is this point right here. And as you can see, what we do then is we simply connect our points, and we end up with what is indeed the graph of a line. Makes sense because remember the title of this section was all about linear functions. So really you should be getting lines here pretty much all throughout the section today. I'll give you a hint. If x doesn't have an exponent on it, chances are it's going to be the graph of a line. If x has an exponent on it, if it's x squared, x cubed, x to the fourth, chances are it's not going to end up being a line. All right, let's go ahead and continue on here and take a look at example number 2. Example 2, the fastest moving tectonic plates on Earth move apart at a rate of 15 centimeters per year. Scientists began studying 2 parts of these plates when they were 30 centimeters apart. Write a linear function that describes the movement of the plates over time, then make a graph to show the movement over 4 years. Okay, so let's start off here with the function. Now you already see what the function is. Let's see if we can figure out why the function is what it is. Now, one thing we do have to know here is what they want us to label things. As you can see looking at the graph, they decided they want the number of years to be on the x-axis. So when I go to write a function here, x is always going to represent some number of years. Y is going to represent the distance, and I know that because they've labeled the y-axis distance. Okay, so let's take a look here. All right, we're going to come here to this second sentence here that says scientists began studying the 2 parts of these plates when they were 30 centimeters apart. So start off, you've got these 2 plates, tectonic plates. And this is going to be a terrible drawing of what tectonic plates are, but it'll work. All right, when it starts off here, there's 30 centimeters in distance between the 2 plates. All right, and then as we go over time here, it says in the first sentence that they move apart 15 centimeters each year. So after the first year of studying now, the plates are now going to be 45 centimeters apart. Why? Well, they were added 15 more centimeters of distance between the 2. They were already 30 centimeters apart. Add another 15 at the year of end of year 1 is how I get to 45. All right, when I get to year 2, they're going to move another 15 centimeters apart. So they're not going to be 45 centimeters apart anymore. Now they're going to be 60 centimeters apart. All right, and then as I go to year 3, they're going to be another 15 centimeters apart. So now they're going to be 75 centimeters apart. And we can keep going down the list. Now they want us to write a function that describes that. Well, let's see here. Start off, they're 30 centimeters apart. So we're sure they have 30 centimeters in distance between the 2. What am I adding to that? Well, let's say I was going to year 1. What formula could I solve to figure out where they were at year 1? Well, that would be adding 15. Okay, let's go to year 2. Well, how can I do that with the same setup? Well, if it was at year 2, I would change this to 15 times 2. 15 times 2 is 30, plus the 30 is how I get to 60. Let's say I was at year 3. What would this be? Well, it would be 15 times 3. 15 times 3 is 45, plus 30 is 75. Now, the differences here, all right, is they're just asking me to write a general equation. So instead of 1 year or 2 years or 3 years, we're not going to know how many years. So instead of 1 or 2 or 3, this here is going to be x. So that's 30 plus 15 times x. Now you might be looking at this and going, well, wait a minute, what you have there is a little bit different. No, not really. All they did is they wrote the 15x part first, all right, which isn't a big deal. It's just flipped around. And that's going to always equal my total distance apart these are at any given point in time. Now, let's go back and make sure we understand this. All right, year 1 here, when I started and we wrote year 1, I didn't write a 1 here. I just wrote plus 15. But think about it. 15 times 1 is still going to be 15. Let's come back here and make sure this makes sense. The beginning of when the scientists study, year 0. Well, if I change this to 0, 15 times 0 is 0, plus 30 is 30. Well, again, at the beginning of time, they are 30 centimeters apart here. When the scientists start studying, they're 30 centimeters apart, so that makes sense. Okay, so we've got our equation here, and you'll see why coming up in a section soon here, why they wrote it like this, because this is actually called slope-intercept form, which is a way we can graph without doing all this little extra work here, but not for today. So let's go ahead and make our table here. You're going to pick some inputs. They picked 0, 2, and 4. Now luckily for us, we've already done the work here. At 0, year 0, they were 30 centimeters apart. At year 2, they were 60 centimeters apart. The only one we haven't figured out is year 4. If I change x into 4, that's 15 times 4, which is 60, plus 30, which is 90. So year 4, plates are now 90 centimeters apart. All right, so now we're going to make ourselves a little graph. Now, as you can see, looking at this particular graph, they only gave us quadrant 1 because they're only looking at positive values here. So they didn't draw these ones, quadrant 2 out here or quadrant 3 or 4 down here. We don't need them. It doesn't make any sense for this graph. All right, so when the x value is 0, the y value is 30. So at time 0, it means I'm not going to have to go right to get there. All right, I'm going to go up to 30 and put a dot. The second one, 260. So at 260 means I'm going to go right over to 2 and then up to 60 and put my next dot. Now, that would be enough, of course, to establish a line because it only takes 2 points to make a line. But they did one more here, 490. For 490, you're going to go right to 4 and up to 90 and put your last dot. Connect your points, and there's the graph of your line. Again, remember, things here today should be lines. So if you're getting something else, chances are you did something wrong. If you have something that ends up graphing perhaps like this, right? Well, that's almost a line. Chances are you just made a mistake right there. All right, so go and try and analyze your mistakes instead of just saying it's wrong, I don't know. Find the one little mistake you may have made, and that'll probably fix what ails you. All right, last one here, we're graphing the linear function y equals 3x plus 1. All right, so let's make ourselves a little table here. We're going to pick our own inputs here. I'm going to pick 0, 1, and -1 like we did earlier. All right, so first time through, I'm going to go into this function and change x into 0. 3 times 0 is 0, plus 1 is 1. Second time through, I'm going to change x into 1. 3 times 1 is 3, plus 1 is 4. Last one, -1. 3 times -1 is -3, plus 1 is going to give me -2. All right, so now when we talk about graphing here, remember, we just combine our x's and our y's, and that's what we graph. So I'm combining these two. So I've got 0, 1, and 1, 4, and -1, -2. All right, well, let's look at graphing those. 0, 1 means I don't have to go right or left, because on the x-axis, 0 is right at the middle. And then I've got 1, which means I'm going to go up 1 and put a dot. 1, 4. 1, 4 means I'm going to go to 1 on the x-axis and to 4 on the y-axis. When I pull together where those meet, that's this point right there. Then last one, -1, -2. For -1, -2, I'm going to go to -1 on the x-axis and -2 on the y-axis. Pull together to where those meet, connect my line, and there's the graph of the linear function y equals 3x plus 1.